Okay, so I have now only 17 minutes to talk about Lambda, but hopefully Werner already did an introduction of Lambda in his keynote. So I will start from the problem that motivated Lambda. If you take a simple problem like this one, like let's say you want to create a service that does the thumbnails of the images of the picture your users upload, right? So how do you do it if you want to be absolutely resilient, scalable, and so on? So if you want to follow all the architecture best practices, you're going to end up with something like this. So you're going to end up with an architecture where the first fleet of EC2 instances are going to be used to absorb the images that you're uploading, right? They're going to store the uploaded images into S3 because you don't want to lose those images. You want to store them for high availability. The metadata is going to be on a small cluster of relational databases over there. In the middle, you see SQS. So it's going to be a queue to put a message that a new image to be scaled down has arrived. And at the bottom, you have another fleet of instances who are going to work only in rescaling the images, right? So for a very simple problem, like rescaling an image, if you want to do it absolutely reliably and from a scalable perspective, you have to do a whole bunch of things that at the end add a lot of operational overhaul because you don't know precisely when the upload has finished. Right? The only instances that can know when the image has been received are the EC2 instances, but you don't want to store data there because if for whatever reason an instance dies or you lose data on this instance, well, you have to start again the whole process. So if we go back to what is Lambda and paradigms that has been promoted by things like languages like Lisp or like perhaps more recently now Scala in Java, the idea is to really separate the function from data, a concept that we already see a lot in architecture. When we want to build scalable architectures, we want to have like completely stateless architectures. So from a code perspective, it's the same. We try to have code functions that have the least amount of state, or like, for example, in objects, the least amount of properties that keep data as possible. And you want to put all that in code, which is called Lambda Functions. So Lambda itself is a service that executes code based on events, as simple as this, right? So as we saw this morning, so we can use it for many different cases. So you have data that has changed in a DynamoDB table. You can trigger a Lambda function, exactly as you will do it like in old school relational databases when you have like database triggers. And the database trigger can, for example, copy and change the data to another table, send a notification, basically do whatever you want. Another example will be CloudTrail. So this is a service that puts logs in a JSON format of everything that happened on your AWS account into an Amazon S3 bucket. Right, so you could have an S3 event that every time a file is received, I'm going to trigger a Lambda function, and if something is weird in this data, I can send a notification, right? Or like you can have like in the IoT custom functions, or even like a last one that we saw recently in the AWS blog is you can write your own auto-scaling feature based on events that you trigger on Lambda. So here it's an auto-scaling mechanism that allows you to scale containers, to scale an Amazon ECS cluster and add or remove containers on this. So all those details are on the AWS blog. So I want to focus on go back to this case, the one that we opened. That is, I put an image into Amazon S3 and I need to create a thumbnail from this. So let's build this. So I'm going to go to the management console, and I'm going to go back here in US East, let's say. So Lambda is available on multiple regions, including Europe. So it's available today in US East, US West, and Europe. So I'm going to create a function. And this function, I'm going to use it to create the thumbnails. So I'm going to call it thumbnailer. Okay. So now, the code Lambda can execute as of today is either JavaScript with Node.js or Java code. So we're looking at adding other languages in the future. Today, those are the languages that are supported. So either I submit the code directly like this, if I have like a very simple, quick, and dirty function that I wanna add, or I can upload a zip file. This is what I'm gonna do. And this is very interesting because a Lambda function is executed within a closed container. So my zip file can contain, for example, statically linked libraries that I need to do any kind of action. So I can add pretty much anything I want, right? So in my situation, this is the function that I'm gonna upload. It's perhaps a bit long, but in fact, it's pretty simple. So for those who don't know JavaScript, at the beginning, what I'm preparing is a couple of variables here. So I'm declaring the bucket that received the image, the bucket that I'm going to use for the output. Then I'm going to do a couple of checks. That is, if I'm not having like the same source and destination bucket, if the file that I received is an image or not, and then I'm going to execute those actions. First, I'm going to get the image from Amazon S3, so I download it using the AWS JavaScript SDK. Then here I'm going to do the scaling. Behind the scenes, I'm using image magic. The wrapper function that exists here is just a call to image magic, a very well-known library to manipulate images. And then at the end, I'm going to put back the result into S3 with a put object function. And that's pretty much it. At the end, I call context done. This is the way to say to Lambda that the function finished. Obviously, there's other ways to finish a function. I could, for example, raise an exception or like crash my code. Those are also like good ways to finish the function. So, so the code is here. The function that I just opened is here. Now I need to add a couple of libraries that I use. So at the beginning here, you see that I declare a couple of libraries. So the AWS SDK is included by default in Lambda. So I just have to install the async lib library and the wrapper on image magic. So again, for those who don't know Node.js or JavaScript, what I'm doing here is using like a package manager, something like a composer in PHP or gems for Ruby, for example. And now I have this folder created node modules. So I'm just going to create like a zip file from this that I'm going to put on the desktop, and I'm going to upload the function.zip. Okay, so I have my bundle. It's here on the desktop. So I just go back here. So it's okay. So the handler is the name of the function who's going to execute it. Will execute the code. You see it here. So this is the name of the main function that I'm going to call. And then I'm going to add a role to this function. So this is very important because the Lambda function, as you saw, has access to the AWS SDK. So theoretically, a Lambda function can do pretty much anything you want on your AWS account. A Lambda function can create an instance, can kill an instance, snapshot volumes, everything you want, but you have to give access to it. So here I'm gonna restrict the role. I'm gonna give access to give to this function only a very restricted role that only allows it to go into a specific S3 bucket and download and upload images. The function is not even able to create a bucket or delete a bucket. It can only upload and download images because that's the only thing I want, right? And then this is the way you adjust a Lambda. So you select the amount of memory that you're gonna allocate to this function. So 128 megs is enough, and then the timeout. So I'm gonna execute this function for a maximum 57 seconds. I'm gonna come back to this later. So I'm creating the function. The function is ready. Now I'm going to create the buckets to put the images. So I'm going to go back to the console. This time I go to S3. And I'm going to create 2 buckets. So TLV demo LBD. And I'm going to put it here in US. And I'm going to create another bucket. So the reason why I'm creating 2 buckets is an interesting one. As you saw, Lambda functions are going to be triggered by events. Every time I put something into the bucket, I'm going to trigger the Lambda function, right? So if I'm only using 1 bucket, and if the result of my thumbnail operation, I put it in the same bucket, I'm going to trigger the function again. And I'm going to do like infinite loops of thumbnails and so on. So of course I can add a check on my code, but I don't want to do that. I mean, I just create 2 buckets and it's good enough. So the buckets are empty. Going back to Lambda. Now the only step is I have to add the event source for this function. So the event source here is going to be a bucket. So let me refresh this with the latest buckets we have. And so it was TLV demo, and the event type is put. So every time I put something on this bucket, it's going to trigger the Lambda function. Okay, so going back to the bucket, you see here there's going to be a couple of metrics that we're going to see later, metrics that are linked to CloudWatch. So here I'm back on the TLV demo bucket. I'm going to upload an image. Okay, so you always need pictures of cats when you do a demo. So by the time we upload the image, so if you look at the Lambda documentation, in less than a second, the event in Lambda is going to be triggered. So if I don't have an error, the thumbnail should be already created here. Here it is. Okay. You guys are really nice. I just created a thumbnail of a cat, and you applaud me. So later on, there's going to be way better stuff. So this is just a cat, right? Okay. So I think you get the idea. So you have all the information here as well. So the last thing I wanted to show you, I don't have much time, is the invocation logs, because you're going to have all the information you need regarding what happened on your function on CloudWatch. So here I'm going to the logs, and you see, for example, it's a little bit at the bottom of the screen. So let me show you this. So you see here the duration was 5,000 milliseconds, so 5 seconds. And I consume, apologies for people at the bottom, but there's a line saying that I consume 57 megabytes of memory. So this is what allows you to fine-tune how much capacity you provision to your function, because this is the billing mechanism that is going to be used for Lambda. Okay, so quickly getting back to this, what I wanted to show you here is also that there's absolutely no infrastructure to manage. You write your code, and then you zip your code and you give it to Lambda and it works. Also the best thing is that there's no magic that we apply on the code. That is, if it works on your machine, it's going to work on Lambda. And you can also simulate Lambda on your machine by directly giving to the function the parameters we give. So here, if you go back to the Lambda console, what I wanted to show you is that you can test a function yourself by giving it the information that an S3 bucket will give him. So this is the data here that we give to the function when we call it. So you take this, you put it on a file on your laptop, and you can call your Lambda function locally. That's exactly what we're going to do. Okay? So there's a couple of GitHub projects that you can find that will help you test your Lambda functions locally. Okay, the second point is very interesting, is you have automatic scaling with Lambda. That is, you don't have to think about how much resources, how much nodes I'm going to shard to execute my functions. And perhaps this is one of the things that made Werner so excited about Lambda, and this morning he mentioned it as well, is that I think this is one of the first true pay-per-use services. Because if you think about it, Amazon EC2, it's more you pay for what you provision. Okay, because if I start an EC2 instance and I don't do nothing with it, I'm still paying for this EC2 instance, right? But here I'm only paying for the execution time of my function. So if I only execute my function once per month or 100 times per second, I only pay for the execution time. So this is true pay for what you use. Okay, a better example, because this was just creating a thumbnail. So let's see, for example, a photo sharing application that works without any EC2 instance, because that's the exciting thing that Lambda allows you, is to create serverless infrastructures. So this is the high-level architecture. You see at the top, you have the Lambda function with the role. You see the source bucket, where we're going to have the images. Here, the thumbnail bucket. I'm going to create a DynamoDB table for the list of my items. And the website is going to be statically hosted on an S3 bucket. So to start, I upload the HTML files of my website on this bucket. Then when the browser comes and does the request, is redirected to the page with route 53. So it gets the HTML page, gets the JavaScript code. With the JavaScript SDK that is on the browser is going to do an API call to DynamoDB to get the list of the images for this specific user. So now I can build the HTML code, and I just have to download now the thumbnails from the buckets. And now you have the cats, right? But just one thing that I didn't mention is, what about the authentication? Right? Because you can't do API calls on DynamoDB without being authenticated. So you could also do a completely serverless authentication mechanism. And I'm running a little bit out of time, but this is already implemented by Danilo. So Danilo is going to come later today. He's going to do a couple of demos here. He has a project called Lambda Auth on GitHub, and it's an authentication mechanism that is completely based on Lambda and DynamoDB. So just to do you a quick demo on this, apologies for the design of the UI. We did it very, very quickly with command line tools. So this is a static HTML page with JavaScript embedded on it, like very, very old school JavaScript. So here I'm just giving my credentials. And this is checking on a DynamoDB table. Now a Lambda function received the call. Checked on a DynamoDB table. Let me refresh it. And now it's going to use another service called Cognito to get an identity. So the identity will give me credentials, and those credentials are going to allow me to do the query on DynamoDB. So you see now I'm logged with the hash identity. And now that's it. So the images for these users are being refreshed and downloaded dynamically. So this is a complete architecture that is serverless and that runs completely on the browser. And if it runs on the browser, you can have exactly the same architecture for mobile applications by using the AWS Mobile SDK. Just 1 minute, I wanted to finish with the pricing. The granularity of the pricing is by 100 milliseconds. So even for very, very simple things like, for example, checking if an email address is valid, it makes a lot of sense to use Lambda. The free tier is quite generous. You see that the first 1 million requests per month are free, and then it's pretty much 20 cents per million requests. And this is why you pay by execution time. Okay, so I'll let you check the details. I think you'll be convinced that Lambda is way better to do these granular executions. And with that, thank you so much for your time. See you for the next demos later.